Hi there, welcome to another video from Hegarty Maths. It's Mr. Hegarty here. It's our second video on Venn diagrams for probability questions. So let's start with a question we've already answered on Hegarty Maths. Double check you can do the following. And hopefully you got the following answer. Now that was done on the previous video, so do go back there and double check you can do that if at all you have struggled with that question. So we're continuing with similar questions to these, other than they're going to be slightly more complicated and involve maybe more sets in our diagram. So let's have a go. Let's get straight on and pause the video, try this question. So, going through this, what's slightly more difficult about this question is that there seem to be three categories. People run, swim, cycle, or they can do any combination of each of those. So, there are three things going on. So, when we draw our Venn diagram, let's draw a Venn diagram with three circles. Labeling it up, out of the 100 people, we know that our universal set is 100. We know they are either runners, so let's call that capital R for run, swimmers, capital S for swimmers, and cyclers, capital C for cyclers. And we are told various pieces of information about whether they run, swim, cycle, do both, do all three, or do neither. So let's try and populate our diagram. The most important thing to start with is the number of people who do all three, and we're told that actually at the end of the paragraph here 25 do all three. So let's pop 25 there in the intersection between R, S and C. Okay, the next fact, 35 run and cycle. So therefore we know in total there must be 35 people in the intersection between run and cycle. Now given there are already 25 there must be 35 subtract the 25, 10 in this part here. They are the people that run and cycle but do not swim. Let's keep going with this information. Next we've got 30 swimmers and cyclists, so let's go to swimmers and cyclists. We know that 30 people in total need to be in this intersection here. There are already 25 in this part, so we do 30 subtract 25, which would leave us with 5. Let's keep going. 40 run and swim, so we know that there needs to be 40 people in this intersection here. Given that there are 25 already in there, we do 40 subtract 25, which is 15, and we have filled that in. Now let's keep going up and see if we can fill the whole thing in. We know that 60 in total cycle, so we know for sure that in this whole circle here there needs to be 60. 10 add 25 is 35, add 5 is 40, so in this section here must be 60 subtract 40, which is 20. What about the next fact where we're told 48 swim? We need to know for sure there are 48 in this circle. 15 add 25 is 40, add the 5 is 45. So we know we must do 48 subtract 45, which would give us 3 there. And let's use our last piece of information, 65 run. So 65 must be in this circle. We've got 25, add the 15 is equal to 40, add the 10 is 50. So we do 65 subtract 50, which would give us 15. We are nearly there. We are not quite finished. We do need to put how many people outside. So we add all these numbers up, and if we add the numbers up, we get 93. Now we know the whole thing must add up to 100. So for this section here, we do 100 subtract 93, which is the sum of all these numbers here, and we would get 7. That is our fully populated Venn diagram. Now we can answer any question with relative ease. It says, find the probability that a randomly selected person from the survey takes none of these type of exercises. Well, there are 7 such people out of a total of 100, so it's clearly 7 out of 100, and we've done that one. Next one, the probability someone swims but does not run. Let's highlight that section. Swimmers but not runners are these people here. There are 3, add 5 is 8 of them out of a total of 100. So it's 8 out of 100, which we can of course simplify, dividing top and bottom by 4 to get 2 out of 25. And the next one, it asks us how many take at least 2 types of exercise. So let's colour those in. At least 2 means you take 2 exercises or 3. So it's these people, these people, these people, the people who take 2 exercises, and these people. So if we add those up, we get ourselves 55. So we do 55 out of 100. And again, we can divide top and bottom by 5. We will get ourselves 11 out of 20. The last question here, it asks us, Jason is one of the above groups. So Jason is certainly in that 100. And it says, given that Jason runs, so we know for sure that Jason is in this circle here. He is in the runner's circle. Find the probability that he swims but does not cycle. So we've got to think to ourselves, we know for sure one fact about Jason, he's in the runners, and in the runners there are 65 people. It says, given he runs, find the probability he swims but does not cycle. So let's have a look at swimmers but not cyclists. These 15 people are the 15 people within the runners that swim, but they also are outside the circle for cyclers. So it's going to be 15 out of 65. And we can divide top and bottom by 5 here, and we would get ourselves 3/13, and we're done. Last question. Pause the video and have a go at this. Okay, in this scenario, people coming out of a cinema were asked whether they ordered popcorn, nachos, hot dogs, both, all three, or neither, and they were the results. So it's a typical Venn diagram. Let's start by drawing the Venn diagram. 3 overlapping circles. Why don't we call this capital P for popcorn, capital H for hot dogs, and capital N for nachos, let's say. Then we know that the number of people in the universal set is 145. And let's try and go through our facts. The first key fact we're told is 15 order all three. So 15 can go in this section here. We're then told 20 ordered popcorn and hot dogs. So popcorn and hot dogs, there should be 20 people in this overlap. There are already 15 people here. We do 20 subtract 15 to get that 5 people must be here. And we've used that fact. Going on, we've got 26 people ordered nachos and hot dogs. So let's look at nachos and hot dogs. 26 people need to be in this overlap. 15 are already in there. We do 26 subtract 15 and we get 11 go there, and we've used that fact. Next one, 22 ordered popcorn and nachos. 22 people must be in this intersection. 22 subtract the 15 would give us 7 people there, and we've used that fact. Now we're nearly there. We're also told 43 people ordered popcorn. Well, 5 add 15 is 20, add the 7 is 27. So in order to work out the number of people here, we would do 43 people that ordered the popcorn, take away 27, and 16 people must be here. We've used that fact. 40 ordered nachos, so 40 people must be in this entire circle. Adding these up, 7 and 15 is 22, add 11 is 33. We want this whole thing to add up to 40, so 40 subtract 33 is 7. And this one here, we're told 44 ordered hot dogs. So this whole circle must add up to 44. 5 add 15 is 20. Add 11 is equal to 31. So if we do 44 subtract 31, we get ourselves 13. We're nearly done. We just have to check how many people must be outside here. So if we add up those numbers, we get ourselves 74. So how many people must be outside? 145 subtract 74, and you get yourself 71 people here. Now some probability questions that are going to be really easy to answer because we've got a fully labelled Venn diagram. A cinema goer is chosen at random. Work out the probability they ordered all three. There are 15 such people out of a total of 145. So 15 out of 145, and you can simplify that fraction. Dividing top and bottom by 5, it simplifies to 3/29. Next, the probability that they ordered popcorn but not nachos nor hot dogs. So just the people who ordered popcorn, but they couldn't have ordered nachos or hot dogs. They're just these 16 people. So it's simply going to be 16 out of 145, like that. And that doesn't simplify. Next, the probability they ordered nachos and popcorn but not hot dogs. So let's just think about that. The people that ordered nachos and popcorn but not hot dogs. So nachos and popcorns are these people here, but they can't have ordered hot dogs. So there's just 7 of them out of a total of 145. So 7 out of 145, like that. And the last one, the probability they ordered nothing. Well, that's clearly 71 out of 145, and we're done. Okay, the last question, one of these given questions, it says a person is chosen at random. That person ordered popcorn, so you are only interested in the people who ordered popcorn. Given this fact, what is the probability that they ordered exactly one of the other two selections? Now, out of the people in this section here, and you know how many there are, the people that ordered popcorn, there are 43 of these people in this section. In order to have ordered exactly one of the other items, they can't be this person because this person only ordered popcorn, so they can't be them. They can't be these people because these people ordered 3 items, so they must be these two. These are the other people that ordered hot dogs and popcorn, and these are the people that ordered nachos and popcorn. So it's 7 add the 5, which is 12, and it's 12 out of a total of 43, and that is our answer for this question. So that's it for this video. Thanks loads for watching.